All right, you guys, we're going to be taking a look at 6.3 today. So we're going to be graphing some square root functions. You can forget inequalities. All right, we're not going to focus on inequalities. We are just going to explore square root functions. All right. First things first, as always, when we don't know how to graph something, I guess we have graph parabolas. The inverse is what we don't know how to graph, and we'll kind of go into things for a second. All right. So I have a function. All right. Some of you might be curious as to why I restricted the domain. Well, I restricted the domain because if I were to graph the entire parabola here, it would fail the horizontal line test. Okay. So what I did in this case is I restricted my domain so that only half of the parabola is there, which allows it to pass the horizontal line test. All right. Which means the inverse is a function. So the question is, if I switch my x and y, I wind up with x equals y squared, then the inverse is going to be square root of x, and that restriction still holds true. Okay, so we only have positive values. So I don't do the plus or minus in this case. I just have positive x, and my domain restriction is for the x values, only positive x values. Okay. Again, looking at how we would graph square root functions, well, if we struggle with that, we can plug in numbers. And these numbers are actually super important. So I'm thinking of perfect squares. The reason I want to choose perfect squares is it's going to make your life a whole lot easier when you plug them in. Because what's the square root of 0? Well, it's 0. What's the square root of 1? 1. What's the square root of 4? 2. All right. And you can see that's what we're going to be graphing today. All right. So we're going to be graphing square root functions. They're going to be, half a parabola essentially that opens to the right, and it's going to go up or down. We could have an instance where we have something like the square root of negative x, and then it's going to actually open the other way, like that. All right. So just kind of be mindful of those situations as we go through things. But let's get to the meat and potatoes of the day. We're going to be graphing these functions. All right. I always like to start with the table. I always like to pick 3 points, and I would encourage you to focus on what's under your radical today. Okay. So if I was to pick an x value that gave me 0, again, 0 is a really nice square root, I would want to pick -3, because -3 plus 3 is 0. Square root of 0 is 0. 0 minus 4 is -4. All right. If I picked x to be -2, -2 plus 3 is 1. The square root of 1 is also a very nice number. All right. Square root of 1 is 1. 1 minus 4 is -3. I then am thinking of another perfect square, which is 4. What number plus 3 is 4? Well, a 1. 1 plus 3 is 4. Square root of 4 is 2. 2 minus 4 is -2. All right. So the trick is to make sure whatever we plug into our x value makes what's under our radical a perfect square. Then we're going to wind up with some nice rational values, in most cases integer values, in our y column. All right. So we have -3, -4, -2, -3, 1, -2. All right. I'm going to come back to the domain and range after we finish this next one. All right. All right. Same idea is true here. All right. We're thinking of what makes that 0 to kind of get the graph started, which is a 1. All right. 1 minus 1 is 0. Square root of 0 is 0. 0 times a -half is 0. 0 plus 3 is 3. All right. The next one, normally we plug in, a 2. Okay. Square root of 1 would be the next one. I'm going to kind of put this here. All right. The reason I'm not going to pick 1 as a perfect square is because I have this fraction up front, right? I don't really like that. All right. I'm kind of thinking ahead. if I plug in a 1 or plug in, you know, the square root of 1 is 1, 1 times a half is a half, 1/2 plus 3, then I'm going to wind up with some fractions in my y column. I'm going to skip that, and I'm going to try and figure out what gives me the square root of 4. All right. So I'm going to have to plug in a 5. 5 minus 1 is 4. Square root of 4 is 2. 2 times negative 1/2 is negative 1. Negative 1 plus 3 is 2. All right. The next perfect square would be 9. Again, if I get the square root of 9 is 3. 3 times a half, that's going to be a non-integer value. So I'm going to skip ahead to 16. What gives me 16 there? Well, about 17. 17 minus 1 is 16. Square root of 16 is 4. 4 times negative 1/2 is negative 2. Negative 2 plus 3 is 1. All right. So we have our 3 points. We have 1, 3, 2, 3, 4, 5, 2. And then 17, 1 is going to be way over there. But it's a much flatter curve. Okay. Big thing we're going to want to talk about today is domain and range as well with these graphs. Hopefully you are kind of seeing something here. I'll get that out of the way. I'll get those out of the way. Any indications about our domain and range based on our pictures? Well, hopefully on the case of A, you see that our x values have to be greater than or equal to negative 3. That is correct because we can't square root negative numbers. Looking at our range, it looks like our values are greater than or equal to negative 4. Okay. I'm not going to say anything quite yet. As we go to part B, the domain looks like our x values are greater than or equal to 1. Our range, in this case, it's going down, and our range values are no larger than 3. All right. Again, I'll draw your attention to the equation itself. In this case, for my range, I'll draw your attention to that a value out front and how that impacted our sign. Okay. And then we'll talk about the general form here. Yay! It's H and K again. All right. So this is about the 4th time we've seen H and K values. Remember, H is going to be that movement left and right on my graph. K is going to be that movement up and down. In this case, H and K are tied directly to our domain and range. That A value out front gives us the orientation and shape. So is it going to be a really flat, you know, parabola? Or is it going to be, you know, a very steep parabola? All right. And then also if A is negative, your graph is going to open down. If it's positive, it's going to open up. Okay. So you can pause it there if you want. I'm going to scroll back up so you can kind of see how that equation makes sense with the values we have in those 2 problems. And then we're going to go on to the last question here. All right. In these instances, it's really important to pick points that are conducive to your work. Okay. And I will tell you on a quiz, I'm not just going to give you a single point like it is here. I will make sure to have 2 clear points highlighted for you because that's going to make your life a whole heck of a lot easier. So we have an end point at 3, negative 1. We have another point on our parabola at negative 2, 3. We've done problems just like this with parabolas. Okay. So we're going to take our standard form. All right. There we go. So we have our standard form of our square root function. Now our objective is to solve. All right. We want to write the square root function. So we're going to start plugging in values. Well, I know that that endpoint is going to be my H and K. So I can plug in -3 here. I can plug in a -1 here. I know that my other point is going to be my X and Y. All right. So we wind up with, whoops, that should be a -3. which makes that a -3. All right. Once we plug in our HK and then our X and Y, you'll notice we have one variable left. We should be able to solve. -2 minus a -3, all right, and -2 plus 3 is 1. So we have a times the square root of 1, which is just a. All right. And we add 1 to both sides, so a is -2. So my square root function must be -2 square root of x plus 3. And then that -1 should be on the outside of your radical. Okay, so today a lot of graphing with square root functions. Again, perfect squares today are your friend. 0, 1, 4, 9, 16, 25, 36, 49. Think about those numbers as you are creating your tables. Use your graphs to create the domain and range if you don't know just from looking at the equation. And yeah, that's it. If you have questions, let me know. Shoot me a message, ask me in class. But that's the assignment for the day. I wish you the best of luck.